Welcome back to my channel, Statistics for Applied Linguistics. I'm Dr. Marnie Menegra, and in this video, we are going to look at the linear regression. So I'll give you a brief introduction as to when we would use the linear regression, and then we're going to look at how to do the linear regression in JASP, along with going live in JASP at the end of this video. Now, also, please keep in mind, we're going to do different videos on how to use the data from a linear regression to make predictions in a different video, along with how to do the write-up for a linear regression. So we'll do that in a different video as well. So first, what is a linear regression? So a linear regression is similar to a correlation, but it provides different output. And this test can be used in an experimental study or when analyzing existing data. As an example here, so if I wanted to use existing data, I might be looking at trends in an area over a period of time. This is existing data, and I might be comparing one region to another. Otherwise, I could be looking at my own study. In this case, we're looking at analyzing the grades of a student compared to the hours studied. So that might be a new study that I'm doing. Okay, regression, correlation, ANOVA, and t-tests are all part of the general linear model, or the GLM. So you will find data from these other tests when you're doing a linear regression. So this is where the output is a little bit different from a correlation. Also, where t-tests compare categorical variables, a linear regression uses continuous variables, which allow us to make predictions. So you would use a linear regression to show a causal relationship. Unlike with a correlation, we cannot get a causal relationship. We have an assumed relationship with a correlation. We can use a linear regression to forecast an effect. So what is the effect going to be going forward, or also the trend? We can use it for trend forecasting. How is this trend going to continue in the future? So we can also use a regression equation to predict future events. And the regression equation tends to be y equals b plus mx. And we would find this information in the JASP output. Now, if in your study you're not looking at making predictions for future events, you don't need to worry about this. Again, we'll look at this in a different video. So a few things to keep in mind when doing linear regressions in JASP. Linear regressions are very sensitive to outliers, so you may need to remove outliers before proceeding. Now, if you don't know whether or not you have an outlier, we can check this with the standard residuals in JASP. And the standard residuals need to be between negative 3.29 and positive 3.29. If they are not, you have an outlier. And if you have outliers at this point, then you would go back and check the data, see if there's an error in the data, or if it is a true outlier. And at that point, you would need to make a decision as to how you would want to proceed, whether you want to remove it or whether you should be looking at a different test. So the regression is reported with a capital R and will always be positive, unlike with a correlation, which will show R with positive values if the trend line increases or goes up, or with negative values if the trend line decreases or goes down. So correlations are reported with a lowercase r because they have a single predictor, where linear regressions have two or more predictors, therefore we use an uppercase R. And the uppercase R squared shows the variance where one variable influences the other. Descriptive statistics are needed to write up the model, so we'll need to grab the descriptive statistics in JASP when we go into JASP. And the standardized coefficient will show the correlation. The unstandardized coefficient is used for predictions. So I'll show you how we can see those in JASP as well. So how do we do this in JASP? First, you're going to code the data in Excel. In this case, we're using the same data from the Pearson's correlation. So we had grades in one column and hours studied in another. We're going to save this as a CSV file. We're going to open JASP and open the CSV file, check the labels, go to regression, click on linear regression, move the dependent variable to the dependent variables box and the independent variable to the covariates. And under statistics, click on descriptives and residual. And from residual, then to statistics, and check the standard residuals for outliers. And then under plots, you can click on the QQ plot and the partial plot. So let's see what this would look like. So when we go into JASP, we're going to open, go to the file, and then we use the Pearson's correlation example data. So here we have everything set to scale. We're going to go to regression and click on linear regression this time. And we're going to pull the dependent variable over, which would be grade and hours studied. Now, automatically, we will get these three contingency tables. The first contingency table will show us R with R squared, and we can see 0.803 is the same number that we had from the Pearson's correlation. Now, because this was positive, it showed as a positive number in Pearson's correlation. If it was negative, we would see the negative sign in front in Pearson's correlation, but in the linear regression, it will always be positive. And R square here at 0.644, this tells us that 64% of the variables are interacting with each other. R and R square will also give you the effect size. Now, if we look at ANOVA, here you can see we've got an ANOVA table telling us the F statistic and the p-value. And under coefficients, we've got the t-value and the p-value just right down here as well. Now, then we're going to go under coefficients, and we're going to click on the descriptives under coefficients. We need the descriptives for the write-up. And under residuals, which is just cut off at the bottom there, we're going to click on the statistics so we can get the residual statistics. This is going to tell us whether or not we have outliers. And then we're going to go under the plots, and we will click on the diagrams that we want. The top one is the QQ plot, which shows us how close the data is to R. And then we have our partial plots, which can give us a little bit more information here. So I'm going to stop sharing this screen and we will go directly into JASP. And so once we get into JASP here, you can see that I have Pearson's correlation open. This is the same data. So notice we've got the two different columns here, but this time we're going to go into linear regression from regression. And grade, this is going to be our dependent variable. Hours studied will be our covariate here. And again, you can see R and R squared, and you can see our F statistic and our p-value here with our sum of squares and degrees of freedom. Under coefficients, we can see the unstandardized and the standardized. Notice that 0.803, this is the same as R. Now, where we have 43.440 and 1.009, this is the information that we would use when we're doing the equation to predict future events or future trends. So we're not going to do that in this video. Instead, we're going to go down to statistics. And the first thing we want to look at, first we need to grab our descriptives. They're right here. And that would be for the write-up. But then we need to go into residuals and look at the statistics. Now also, for the residuals, I can go down into plots. And here I can click on the residual histogram. So what are we looking at with the residuals? Here we have the standard residual, negative 2.937, and the maximum is 1.811. This tells us that there are no outliers because these numbers fall between negative 3.297 and positive 3.297. So also in this graph, you can see that nothing really falls below -3 or above +3. So we're good to go with the data here. I'm going to get rid of this information as we no longer need it. And so now we can click on the QQ plot and I can make this diagram larger. No, maybe I just made it a little bit wider. We'll make it a bit larger here. So you can see how close the all of the data falls to the line of R, and then we can get the partial plot. Now the partial plot is just showing below, very similar graph here. But what we can also get with the partial plot is the coefficient intervals. So the majority of the data will fall between these thin blue lines. But if I also look at the prediction intervals, any data that I predict coming forward into this model should fall between these dark blue lines here. So this is how you do a linear regression in JASP. Thank you so much for watching this video, and I look forward to seeing you in the next video.